I am now ready to define def, a function that is going to take some positive integer. I'm going to denote that as lowercase z, and the purpose of this function is to return a list of its prime factors. So maybe an appropriate name for this function will be factor. Let's go ahead and put in our colon, and we're ready to start constructing our function here. Now I am going to initialize two variables. The first is going to be called divisor, and I'm going to take the first prime number, which is 2, and assign it to that variable. So I've initialized the variable divisor. Now I did say that this function is going to return a list of prime factors. So we're going to now create a variable called factor list, and I'm going to take an empty list and assign it to factor list. It's really important to note here that factor list is an object of type list. We're going to need that in just a moment. So now, how do we actually take this positive integer z and start extracting its prime factors and adding it to this list? It actually might be easier if I conceptualize this example. So I'm actually going to remove the z and replace it with some positive integer. Let it be 12. Don't worry, I'll go back and throw in the variables after as we abstract everything. But for now, we're going to use just an example. So the first thing we're going to do is we are going to create a while loop, and we're going to have some Boolean statement here. So this is either going to be true or false. And if this statement is true, then we are going to do something in this code block. And we're going to continue to do this something while this Boolean statement is true. Now, if this Boolean statement happens to be false, then we are going to exit this while loop, and we are going to return the factor list to our user. And we're done. So what is this Boolean statement? Well, it happens to be a test where we take our positive integer, which is now 12, and we test to see if it is greater than 1. Essentially, what we're going to be doing in this algorithm is taking 12 and dividing it by a series of divisors until we actually get to 1. And that's actually what's going to trip this conditional statement to being false. So let's go ahead and start doing something. What are we going to do? Well, I'm going to use an if statement here. So it's a conditional statement. If our positive integer 12 divided by the divisor 2 has a remainder of 0, so 12 modulo 2 is 0. Another way of thinking of this is to a factor of 12. And this is just a Boolean statement, which is going to return true. So I'm now going to be able to move into this code block, where I am now going to take this divisor of 2 and append it to our factor list. Now remember, our factor list is an object of type list, which means it has a method called append. And what are we going to append to our list? Well, that is just the divisor of 2. Now, in addition to that, we are going to change our positive integer. Our positive integer 12 is going to be divided by our divisor, which is 2, which is going to give us a new integer to consider, which is 6. And now we're going to bounce back up to our while statement. The positive integer is no longer 12. It is now 6. However, this Boolean statement is still true. Oh, before I do that, I almost forgot. When we appended 2 to the factor list, we got to do it. We got to put it in the list. So there it is. That divisor of 2 during this step has been added to the factor list. My bad. So let's get back in here. We have this conditional statement. 6 is greater than 1. That's, of course, true. We move into our if conditional statement. The 12 is now the integer 6. 6 modulo 2 is 0. And another way, again, of thinking of this is 2 a factor of 6. Of course, that is true, so I can move into this code block. Again, we're going to take our factor list and use the append method to add this divisor of 2 to the list, and I remembered to add it this time. Fantastic. And then we have one small thing to do here. We need to take our integer 6 and divide it by 2, which is going to give us a new integer 3. We bounce up to our while conditional statement. The Boolean statement 3 greater than 1 is still true, which means I can move into this code block. So now if 3 modulo 2 is equal to 0, now that is false. 2 is not a factor of 3, so I'm not allowed to move into this code block. So instead, I am going to move into this else condition where I am actually going to change the value of my divisor, which was 2, but now I'm going to increment it by 1, giving me a new divisor of 3. Moving up to my while statement, 3 is still greater than 1. We haven't changed the value of our integer here. And now I ask, is 3 divided by 3 leave us a remainder of 0? Yeah, that's true. 3 is a factor of 3. 3 modulo 3 is 0. So this Boolean statement is true. That means I can move into the next code block. We're going to take our factor list and we are going to append that new divisor, which is 3. So let's go ahead and do that. And then we are going to take our value of 3, that's our integer, and divide it by our new divisor 3, which is going to give us 1. We're going to bounce back up to our while loop, and now we have 1 greater than 1. The Boolean statement is now false, which means I'm not allowed to enter this code block, and consequently, I'm now just going to return my factor list to the user, and we're done. So we can see here that I can see here that my factor list is 2, 2, and 3. So those are the prime factors of 12. Now I said I would abstract this, so let's get back up to the top here. We're going to denote our positive integer as lowercase z here, which was a 12. And let's go ahead and initialize our factor list. So it starts off as an empty list. Now for our while Boolean statement here, we are considering when the integer, our positive integer z, is greater than 1. And then we move into our code block if that is true. So we have our if conditional statement. So if our positive integer divided by its divisor leaves a remainder of 0, or if the divisor is a factor of our positive integer, or if z modulo divisor is equal to 0. If this Boolean statement is true, then we can enter this code block. So what are we going to append to our factor list? Well, that is just the divisor. And what are we going to do after that? Well, we are going to take our positive integer z and divide it by our divisor. That's the current divisor, and that is going to allow us to redefine our positive integer. Now, if this if if condition fails, then we move into our else condition here, and that's where we're going to change our divisor. In fact, we're going to take our divisor and increment it by 1, giving us our new divisor. And of course, we can just see that we're incrementing here. So what I could do instead is just replace this with plus equals, and then we have a 1 there. So I'm just going to increment the divisor by 1. Now, of course, this isn't super efficient because we really should be just looking for the next prime number as a divisor, but we're just going to increase to the next one. It still works, it's just not as efficient. And it's done. We have now hopefully defined a function that will factor a positive integer z. So let's go ahead and execute this. No errors, fantastic. And now I am going to go ahead and try it out. So we have factor, and we have one argument, which is our positive integer. Let's try 12. I'm going to go ahead and run this, and it returned a list of its prime factors. I'm going to just for kicks, before we're done, I'm going to put in 1, 1, 2, I don't know, something like this, and we get a list of its prime factors. Super. Fantastic. Thanks for watching. My name is Mark, and we'll see you next time.